Dear students, welcome to the video binomial expansions of 1 plus x to the power of n for values of n that are not positive integers. And now in this part we are going to actually see an extension of binomial theorem that you learn in AS level. Now it is a general binomial theorem and is used when n, which is the power of binomial, is a number other than positive integers, like fractions. It could be negative numbers or negative fractions. Now 1 plus x to the power of n can be written as 1 plus nx plus n times n minus 1 over 2 factorial, then x squared plus n times n minus 1 times n minus 2 over 3 factorial x cubed, and this pattern continues. Now there are 2 points that you need to actually consider. The series is infinite, and the second point, which is really important, expansion is valid when absolute value of x is less than 1, or you can say x between 1 and -1. Otherwise this expansion is not valid. 2.7 expand 1 minus 3x to the power of -2 in ascending powers of x up to and including the term in x cubed, and state the range of values of x for which expansion is valid. I first write the formula of expansion of 1 plus x to the power of n. It will be 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1 times n minus 2 over 3 factorial x to the power of 3. And here, as it says, up to x cubed, so there is no need to continue. So n is replaced by -2, and x means the second term, which is -3x. So expansion of 1 minus 3x to the power of -2 will be 1, n is -2, so it will be -2 times x is the second term, which is -3x plus, then n times n minus 1, so -2 times -3 over 2 factorial, then -3x to the power of 2 plus, then -2 times -3 times -4 over 3 factorial x to the power of 3. Now if you simplify, it will be 1 plus 6x, then plus it is positive, then plus 27x squared, and this one will be again sorry, it is -3x to the power of 3, so then it will become plus 108x cubed. So -3x, then 2 factorial, 3 factorial, yes. Now it says when this expansion is valid, so the second term is -3x, so absolute value of -3x should be less than 1. Now absolute value actually removes the negative, so you can say 3x is less than 1, or we can say absolute value of x is less than 1 over 3, or you can say x between 1 over 3 or -1 over 3. In this interval, this expansion is valid. Now let's solve another example. Find the first 4 terms in the expansion of 1 plus 2x squared to the power of -4, and state the range of values of x for which the expansion is valid. So 1 plus 2x squared to the power of -4. So n is -4 here, and the second term is 2x squared. So it will be 1 plus nx. So -4 times x, which is second term, which is 2x squared, plus then n minus n times n minus 1 over 2 factorial minus 2x squared to the power of then it says up to 4 terms, so to the power of then 2, then next one minus 4, n times n minus 1 minus 5, n minus 2 minus 6 over 3 factorial. Then second term, which is 2x squared to the power of 3. So 1, 2, 3, 4 terms, which simplifies to 1 minus 8x squared, then plus 40x to the power of 4, and here it simplifies to minus then 160 x to the power of 6. It says state the range of values for which this expansion is valid. So 2x squared absolute value should be less than 1. So absolute value of x squared should be less than half, or x absolute value of x, if we take a square root, it would be 1 over root 2. So x should be between 1 over root 2 and negative 1 over root 2. In this interval, this expansion will be valid. Third example actually, find the coefficient of x cubed in this expansion. So x minus 5 over 1 plus 2x. It can be written x minus 5 times 1 plus 2x to the power of negative 1. X minus 5 is a linear function, so we just need to expand 1 plus 2x. I will write it here. So n is negative 1, so it will be 1, and then nx, so which is negative 1 times 2x, then plus n times n minus 1, which is minus 1 times minus 2 over 2 factorial 2x to the power of 2, and I write up to x cubed minus 1 minus 2 minus 3 over 3 factorial 2x to the power of 3. The rest is not really needed, so it will be 1 minus 2x plus 4x squared minus 8x cubed. Then so I rewrite it here, x minus 5. Do not forget to rewrite x minus 5 as one of the factors. Then x plus 2x to the power of negative 1 is replaced by this expansion, 1 minus 2x plus 4x squared minus 8x cubed. Now you are looking for coefficient of x cubed. So how x cubed can be produced here in this expansion? If you multiply x by x squared, so which is 4x cubed, then if you multiply minus 5 by 8x cubed, then it will be plus 40x cubed, then it will be 44x cubed. So the answer is 44. You know, you can multiply and expand all, but there is no need to do that. So it would be a waste of time because coefficient of x cubed is just needed. So this product and this product will be producing x cubed.